I really hope we can fix this thing because they're a bloody nightmare to make. G'day guys, Matt from Hal Heavy Duty. We're an Aussie machine shop that specialises in the drilling industry. And today we are trying to fix the largest water swivel I've ever seen in my life. It's part of the Big Rig project. So they've just finished their first hole. It's gigantic, 3 metre diameter, 1/4 kilometre deep. And what this actually does, I've got a smaller one here so you can see it. It sits on top of the rig, and this allows it to rotate whilst they can pump in water at the same time. Water, air, whatever you're pumping in. They call them water swivels. Now, you're going to see in just a sec, the one that we're going to be working on, massive. And if we can fix it, it's going to be a whole lot of fun. Anyway, let's get cracking. So this is a gigantic water swivel. Now, what we've got to do here, we have to take this inner section. This comes out. It is supported by 2 bronze bearings here that were made out of LG2 bronze, so it's too soft. Essentially, we're going to have to re-sleeve this with phosphor bronze. And this here, when they made it, is made out of a material that's too soft, so we're actually going to get it case hardened. So we're going to pull this sucker apart and have some fun with it. You can sort of see it here. That's an O-ring. Oh. You'll see it when we pull it apart, but this at 5 RPM during operation will rotate around. This is a lubricated bearing, bronze bearing, these are actually automatic, but also manually. Rightio, let's get this up and get him apart and you'll be able to see it better. This is going to be fun. What a mess. And just to put it in perspective, that's a standard size water swivel. That's the Big Rig one. See how roughed up all of that is. That there. Yeah. That was an O-ring. Right, let's get him off. Wondering why I'm not using a big sledgehammer. We use bronze hammers as much as possible in the shop. It just stops steel getting unnecessarily bruised. If we have to, I'll get out the sledgehammer, but I prefer to use just a bronze hammer because it doesn't mark the steel anywhere near as bad. Drillers, on the other hand, they love steel hammers and everything comes back completely wrecked. This is a perfect example. Now, they deserve a medal for how they managed to do that to one of my subs. How? How? They got skills, these drillers. That one needs a medal. Not a bronze hammer inside in a drill rig. Starting to free up now, which is good. So we're halfway. Those O-rings, they would have totally sealed. So they're actually quad rings, what's left of them. Sorry for the background noise, we're a real live machine shop. and Willie is blasting out some dovetails on Godzilla the Mill. So these videos, you're going to hear background noise. We're a real live shop. Anyway, we're going to go give this a bath, and then we'll have an examination and see if we can save it. It's pretty banged up. So you can see here, 2 O-rings. There's a bronze bearing sleeve. You see it when I pull it out. That's all flogged out. So we're going to have to pull this out and re-sleeve it with, this is PB1, so phosphor bronze, much harder than leaded gunmetal bronze. They should never have used that in the first place, but you know, these are all prototypes and you learn as you go. These two, I am going to actually have to not use these as the O-ring grooves as we move forward. I'm going to have to put it into the bronze because the size is going to come down, because this is flogged out. That is munted. It's not great at all. So I'm going to have to put this in the lathe. First step, put this in the lathe to turn it down. I'm going to get this then sent away to be case hardened. That way it'll be a hard surface on a softer surface, well lubricated, and we shouldn't have this happen again. The problem was this is soft, this is not hard enough, and hence why this occurs. So we're going to make some changes, see if we can get it down to size and it still works, and hopefully we can get some more life out of this big boy. Anyway, step 1, we'll turn this down. Whilst that's not perfect, what it actually does is just removes off any high points. Okay. So that we can get it in, same on the outside here. Find the 3 best points to grab it in the CNC. We'll turn this down now. All right, in you go. What I was just checking for is that there's no air gap here whatsoever. And then it's grabbed nicely, so you can see there, no gap. No gap. Old Willie's on the mill there. And no gap. So it's grabbed down on clean surfaces here. There's no gap here and it's pushed in from the end. So that should run as true as possible for what we want to do. That's good. We'll run a dial indicator just to see that there's no true surface, but even with all of the dodginess, as in not the greatest surface, everything that you saw, that's running within 0.1. So that's totally fine tolerance for what I need to do here, because I'm going to be turning it down anyway. Gigantically comical plans. That's what we've got. And these are the 2 surfaces we've got to make true here. We're going to be using our Colchester Alpha 1760, which is the larger of our 2 CNCs. Let's set up all the big tools. We've started using some of this hang surface rust coat on all the tool holders too, and I tell you what, it's made a big difference. The stuff is fantastic. Hang Surfers Rust Coat. Not sponsored, I just like sharing good stuff with you. So we've been with the channel for a while. These got pretty manky, but we've cleaned them, sprayed them. They're actually staying pretty darn good, which is a surprise. And the beast stayed shiny. God, I love that tool. So I'm going to touch off this back shoulder here as my 0 point, and then we're going to turn him down. Before I machine it, you can see just how worn out this surface is. That should be silky smooth, which it will be by the time I'm done. You can just see that was obviously not sealing. That's just from O-rings that have burned into it because it's too soft. Alright, let's do it. Our normal up to 300 measuring tools aren't going to be big enough, so we're going to have to bring out the big gun. $300 to $400, and it'll be just fine. Original size of this was 304, so I'm going to take a mil off each side as my first cut. If the damage is too much, we can't repair it, but I think we'll be right, so let's find out. Pull this lever to stop the feed as that approaches 0. Wind the last, maybe 1/4 of a mil in by hand, and then pull out. Well, surprisingly, and I'm genuinely surprised, that cleaned up first pass. The last one of these I repaired, they had a lot more deep scores and gouges, whereas this one, we're laughing. Beautifully cleaned up that back shoulder there too. All right. You, my little buddy, are off to get case hardened. Done. Beautiful. And as I said, when it comes back on jaw 1, I'm going to put 2 scribe marks here, so little carbide tipped scribe, just so that I know that that is where to position it. Probably not necessary, but I like to do this. Just I got in the habit of it from when I'm threading, because it just makes life way easier if you know where you put it in. Do. That'll let me know where to put it back in. Jaw 1, right there, laughing. Good job, buddy. So the next step in this project, now that the nose has been sent off to get case hardened, we're going to prepare this, right, make some modifications to get rid of this LG2 leaded gunmetal bronze. I'm going to put that phosphor bronze there, which is very beautiful stuff, Now, how do you get this out? There is an easy way and a hard way. Rather than having to machine it and do all that sort of stuff, which is going to make a big mess, there's nowhere to hit it from behind here. That's pressed in flush, and this was an interference fit, so it is in there tight. What we're going to do is, if you heat it up in 3 spots, just heat it up till it glows, and then let it cool, it'll actually permanently contract enough that that'll just drop out. So it's a little tip that a Boilermaker once showed me, actually. So works well every single time. So we'll do the bottom one first, and then we'll flip it over, and we'll do this one, and then we will begin to make the alterations, because see, we'll reuse this for something. You wouldn't think you would, but not much gets thrown out around here. Rather than just turning it into chippies, I'm going to get them to slide out. Well, it's frosty beer o'clock, 5 o'clock, so you can see that's been heated up in 3 sections there. I'm going to go and have an afternoon beverage with the gents, and by the time I come back, that will have cooled and just dropped right out on there. Let's see if my prediction comes true. I have made one bloody big mess today. It really is the most beautiful time of the day here. Anyhow, let's go and see if I was right or not through the shop. Turn you off. No. Can't be far off. Let's have a little closer inspection. It still hasn't fully cooled, so I'm just going to leave it hang there overnight. See what it's like when I come back in the morning. This mystery's been solved. They confessed. They used it as a sacrificial piece and then used a hammer to free the rods up. You can see that actually, mystery is solved. So that took some skill. They just sacrificed this poor dude. Sorry, buddy. But they got the rods out of the hole. So that is how that happened. Alrighty, we're back at it here. There we go. I'm not going to lie, that took a tiny little tap just from the trusty little chrome rod there. Wasn't tight, it just needed a little bit of encouragement. So that's how we got the bronze out without having to beat the living crap out of it. And I assure you, that was not going to come out any other way, because the first time I had to do one of these, before I discovered that trick, it was, I was like a frustrated ginger man in the jungle, just beating the hell out of it. And anyway, things you learn. So that is done. You can see where it was heated up there. But we may end up reusing this for something. It's an expensive bit of bronze, so I don't want to throw it out. But we've now got here, which I'll have a closer look at, that we're going to pop this in the Hulk and do a bit of machining on it. So I'm going to take this other one out first, and then we'll get this in the Hulk. So they're both out now. Good. Alright. And check the size here. I'm actually going to use the CNC, not the Hulk for this part of it. It'll just work out better. Because I can run the CNC as a manual lathe, so we'll do that. Alright, so these inserts, I'm going to have to turn down the outside when it comes to fitting them to an interference fit, but I've got 323 mil worth of material and the gap here is 315, right? So that's what the ID is. So I've got a little bit of wiggle room where I can widen this only by a cleanup. I might go 1 mil out, but I'm going to remove this O-ring groove here and just take that out and slide the whole piece in, so I've got a little bit more bearing material there, and then I'll stick 2 O-ring grooves into the bronze so it'll seal on the spindle nose. I've got enough length just to do that. I've got, what do we got? 108, and the distance there is 105. So we'll just have enough to do what I want to do. We had to get these specifically forged. If I had my time again, I would have made them another 15 mil longer and taken out both of these, which we may do in a further, like if we rebuild them again. But for now, I'm going to take that O-ring groove out and sort this. Much I can do about that. It's cleaned up relatively nicely, all considered. A little bit of chatter, but I'm not worried about that because it's going to be an interference fit press in anyway. Mild. I'm going to check the size and I might do one more pass, we'll just see. So for anyone not a machinist wondering what these are and how they work, it's an inside tubular micrometer and it's segmental. So this part here counts for 200. You probably may not be able to read, it's got it written on there. 200, 50, this segment counts for 50 as well. And I've got a little tiny bit there that's 13. So this, as it sits, 313 mil. And then to measure it in from there, sorry about the focus, I always struggle with this. You can see, I hope, there's another 4.04 mil. So 313 plus 4 is 317, and then that 05. So it's 317.04 is what that came in at. And I had it set up on tool 12 there for 317. So it's cutting 0.04 over, which I'm totally happy with, because I'll just adjust the bronze to suit that. So I'm not going to take another pass, that will be totally fine. I'm going to flip it over and do the other side, make it the same size, so I can machine my 2 pieces of bronze to suit. Happy with that. Righto. So the best surface to dial off is going to be in here, because this actually hasn't been beaten up at all. So this, not great, but this is fine. So we'll have a little look and see how it's running. It's actually not too bad, considering what it is. I can work with that. So I'm going to repeat the process here. Take this from 316 to 317. Remove that little O-ring groove and back up to there. Let's do it. You can barely see it. The corner of that insert is chipped. That's why she's making nasty sounds and vibrating. Index that insert and we're back at it. I find if I just go side to side like this and then just gradually, almost, that's it. Lock him off. And just to make certain, because I will be using these together in tandem, so they both read 316.55. So we're good. And so that it matches the other side, we're going to go 317.05, which is what the other side was. We'll do that now. Last pass. And for those curious, these Colchester machines, they're alpha mode, which is you just flick this little switch over here from CNC to manual or alpha mode. I can then set whatever feed I want and then control the percentage of that over here. So I'm currently running 60% of 0.2, which is 0.12. I can set my spindle speed in RPM, and then if I wish, I can go and check what it is meters a minute. Quite useful, but that will do. And then to set it moving forward, I set the direction, whether I want to feed that way or feed that way, any direction you want, but I want to go this way. And then all I've got to do, pull this little lever, boom, and off we go. Sometimes you'll see me cheat with the just going like 1% of feed and hammering into it, but this is the better way to do it to control your feed. Alright, so I'm pretty happy with that. Just measured it, it's to size. I won't take you through that again, but that's very nice. About the same as the other one, in all honesty. They're both the same size, which is what matters. So now it's time to pull this out, clean the lathe out, and then we'll start machining some bronze. Beautiful. Bloody lovely. Well, I am really happy with how that's turned out so far. So far, so good. I think we're in the clear, so we should see that come together in the next video. But guys, that's it from me. I really appreciate you guys tuning in each week. If you're new to the channel and you want a weekly dose of just heavy duty machining, us making big stuff or fixing stuff that drillers have broken, you know what to do. Hit the subscribe button. And if you enjoyed the video, consider giving it a like, because it really does help the channel grow. And if you are new to this, let me know in the comments where in the world you are watching from. I get such a kick out of knowing where you're seeing this from. Guys, that's it from me. I'll catch you in the comments, and I'll catch you on the next one. What's this, Teddy?
Buggy.
The buggy? Should we jump on?
Jump on.
All right, let's do it. Other side?
Okay.
Other side, okay. Jump on.
Good way.
Oh, the scooter. Come on, let's go for a run, lazy bones. Come on, Penny, let's go. Look at that, Teddy. Wow. Take it now. That's going to be fun. Teddy, what's that? Is that a digger? You want to hop on it? Yeah. Do you like the digger? Like the digger? Digging, digging, digging.